When you hear the word algorithm, it might seem intimidating at first, but it's not as complicated as it seems. The meaning is quite simple. An algorithm is just a list of instructions to solve a problem or perform a task. It tells you what to do step by step until you reach the desired outcome. It's like a recipe for making a cake. Yes, even your grandma uses algorithms. Where it's used? These days, algorithms are in almost everything, not just your grandma's cake. You're watching this video on a phone or computer, right? Those devices use algorithms. Your digital watch uses algorithms. Modern cars drive themselves thanks to sensors and algorithms. When you shop online, play video games, chat with friends on social media, open your email, or watch a video on YouTube, all of this is made possible by algorithms. Even on Mars, there are algorithms. In a broader sense, routines can be considered algorithms because both involve a set of instructions to accomplish a task or solve a problem. Want an example? Your morning routine. You wake up, brush your teeth, have coffee, take a shower, and so on. If you change the order, the outcome might be different, like leaving the house without brushing your teeth. Don't do that, or they'll call you Dragon Mouth. Another example is maps and routes. When you use GPS to get somewhere, it gives you step-by-step instructions. Those instructions are an algorithm to reach your destination. Remember, there are different routes to the same place, meaning there can be different algorithms that work in distinct ways but lead to the same result. But if different algorithms can lead to the same result, how do I know which is the best? Well, in computing, you can compare the execution time between two algorithms using Big O notation. Big O is like a laziness meter for algorithms. You know when you have a task and you want to know how much effort it'll take. Big O does that, but for computers. Big O will be the topic for another video. What's important now is that you know it exists. The structure of an algorithm can be divided into three parts: input, processing, and output. The input is what you provide to the system. The processing is what the system does with it. The output is what you get back. For example, the vending machines. The input is the coin you insert into the machine, and after inserting it, you press a button. The machine then does what it does best. It processes your input. In this case, the processing is when the machine checks the coin, verifies if the amount is correct, and decides which drink to release. Finally, the machine delivers the drink. That's the output. In the context of an algorithm, the output is the result of the processing. Have you ever thought about how ChatGPT works? You type something, the computer processes it, and then it gives you a result. A cake recipe. To make a cake, you need ingredients, mix them and bake them, and in the end, you have a cake ready to eat. So, algorithms are essentially the instructions that computers follow to perform tasks. Just like you follow a recipe to make a cake, a computer follows an algorithm to process data, solve math problems, navigate the internet, or even play a game. It's all about following a series of steps to achieve the desired result. If you have any doubts, leave them in the comments or feel free to visit our website where you'll find a contact section. Yes, this is therapy, $20. See you next time. Bye.